our kind of satiation feelings only kick in 20 minutes after we're actually full. 20 minutes later. So there's a 20-minute period where you're still stuffing yourself and you don't need more food. So humans are literally geared to overeat. Think about the next time you're hungry. Eat some food, and you don't know if you want to eat or not, wait 20 minutes, and then consider if you want to eat or not. Just saying. So, yeah, it's 20 minutes. It's a long time. And it's because back in the day, humans weren't guaranteed 3 meals a day, right? Sometimes they have one meal every other day, or one meal every 3 days. Who knows? You don't know when the next meal came back in the hunter-gatherer days, right? So your body encouraged you to eat a lot of food, and that also encouraged you to store a lot of fat. So we're geared towards fat production and overeating. So keep that in mind next time you eat. Anyway, so yeah, our stomach acts as storage because we can't take all the food we're eating and then just digest it all at once. We can't digest it all at once. We can't absorb it all at once. We just don't have the capacity for it. We'll see why we don't have the capacity for it in a bit. But there's only so much food we can digest per unit of time. There's only a certain maximal rate we can digest and absorb food. And so for the food that we can't digest and absorb just yet, we get a storage inside our bellies. And so this is what stomach, kind of this upper part of the stomach is for the food that is not ready to be digested or ready to be absorbed. It kind of sits in this upper part of the stomach, waiting to be digested. And so if you feel extremely full after eating, it's because this part is bulging. Right? But it's kind of like a conveyor belt. As food digests, the stored food eventually makes its way downwards, kind of inferiorly towards the stomach, and that's where it's going to start digesting. And so this kind of part of the stomach is where we're going to start digesting. Hopefully you take an anatomy and you know these kind of folded parts are called rugae. And so basically the epithelial tissue here kind of look like this, where they kind of have a part here which we'll call a crypt. And these crypts are housing a whole bunch of epithelial cells. So all of these are epithelial cells. And these epithelial cells are different. They have different jobs. Some of them are going to make acid. They're going to make HCl. Some of them are going to make mucus. Some of them are going to make signaling molecules, either paracrine signaling. So paracrine signaling does what? What does paracrine signaling do? It signals nearby cells, local signaling. It doesn't go into the bloodstream or anything like that. It talks to other cells. And there's some cells that do endocrine signaling. So they have hormones that eventually go into the bloodstream and talk to other parts of the body, like talk to your brain, like, hey, I'm full, that kind of thing. And so all of those cells are going to find in this crypt. And so this is the only time I'm going to really show crypt. I'm going to then abstract this into boxes and abstract cells, but just keep in mind that all these cells, they're actually lined in these kind of grooves and valleys of folding epithelial tissue here. And so food will then get digested through acid and some enzymes, and it comes out of the stomach, out of the pyloric sphincter. And when it comes out, it is now considered chyme. It's no longer a bolus. It's now chyme. It's not chyme, it's chyme. So chyme is different in the sense that it's been pretty much digested by acid and some enzymes. So it doesn't have this kind of solid texture that a bolus would. So your bolus is basically food after you chewed it up. If you ever kind of spat out food you chewed up, it's mushy, but it's still kind of solid, right? Chyme is basically kind of like now porridge level, like kind of thickness. It's much more liquidy. It's not nearly as solid as it used to be. And so that's kind of the main difference between a bolus and chyme is kind of this texture difference, this kind of solid factor difference. Okay, so the main part of digestion is acid, and so the main acid used is HCl, hydrochloric acid. And so So here is our generic cell. This is our generic acid-producing cell, and so here is the lumen. This is where the content of our stomach is, and then on the other side is our extracellular fluid, and then you have your capillary here. And so the cell that makes the hydrochloric acid, these are called parietal cells. Remember, they're part of this crypt here. And so this is the pathway they use to create hydrochloric acid. So you're going to see this equation a lot. You take carbon dioxide, have it react with water using the enzyme carbonic anhydrase again, and then they make hydrogen ion and bicarbonate ion. This is the same reaction we saw in our carbon dioxide transport. Same reaction. So what happens is this gets thrown out and it gets exchanged for chloride ion. That chloride ion gets transported out into the lumen, and then this hydrogen ion gets also transported out of the lumen for an exchange for a potassium. And it turns out there is this, what we call a leak channel, that lets calcium diffuse out so it can eventually come back in again. You see a lot of squinty faces. Yeah?
So the acid isn't made in the parietal cells? Is that
No, actually it's not. So the components of hydrochloric acid are put out. So because of this pathway, we have a hydrogen ion, and because of this pathway, we have a chloride ion. And so the components of hydrochloric acid are put out into the stomach. And if you so people think like, well, why don't you just put this out, right? Why are you just putting it as one unit? Well, that's because whenever you mix hydrochloric acid with water, it immediately breaks up into hydrogen ion and a chloride ion. And so if you just put hydrogen ions and chloride ions in water, that's essentially hydrochloric acid mixed in water. We call hydrochloric acid a strong acid. It means it dissociates easily. And it dissociates into two parts, hydrogen and chloride. And so if you put those two parts out into your stomach, you're effectively putting acid into your stomach. Yes? So when we took, let me start highlighting stuff or else I'm going to have a whole bunch of lines. When we took this carbonate ion and we pushed it out of our cell, that was part of an antiport transporter. That was part of an exchanger. So whenever you put a bicarbonate ion out, you bring in a chloride. And then that chloride eventually will be put out onto the other side of the cell. And this brings me to a kind of some new terminology, or semi-new terminology. This side of the cell, I was supposed to draw that in a different color. This side of the cell is called the apical side of the cell. So the hydrogen ion and the chloride ion are being thrown out onto the apical side of the cell. And this side is called the basolateral. The basolateral side of our cells. So this is where the bicarbonate ion being thrown out into the basolateral side, our chloride ion being pulled in from the basolateral side and eventually put out into the apical side. So this is how we put acid essentially hydrochloric acid into our lumen. Yes.
So
Can you just say that again? What goes into what side? Yeah.
So the basolateral side is where the bicarbonate gets put out, and that's where we bring in our chloride on the basolateral side. And then on the apical side, that's where we put out that chloride ion, which we brought in from the basolateral side. And that's where we also put out the hydrogen ion from this reaction. That's put out on the apical side. So on the apical side, we have a hydrogen ion, we have a chloride ion there, and so together that is hydrochloric acid. Yes.
So is the chloride leaving the lumen because of the concentration gradient, or is it just because of the transport?
Oh, you mean moving into the lumen?
Yeah, moving
Moving into the lumen? Yeah, it's because of concentration gradient.
Okay, so it's more through diffusion, so it's not really active transport.
It's facilitated diffusion, yeah.
Okay.
Because ions can normally diffuse through a membrane. So, but yeah, it is. It's not active transport. You're right. Mm-hmm. Yes.
So apical is where the acid is being made, right?
Yes, the apical side is facing the lumen. That's another way of putting it. Well, the basolateral faces capillary. Yes.
When you're referring to the lumen, does that mean the small intestine lumen?
No, there's the lumen of this. There's the lumen of the stomach too. Basically, the inside space of your stomach. That's considered the lumen as well. Lumen is just the space inside a tube.